Okay, so this is the final session, DevSecOps Promises. We've been talking a lot about the basics of promises, agents, promises, impositions, assessments, and how these apply to roles within DevSecOps and cooperation in general. And the thing that's been missing so far is really to talk about boundaries. Boundaries are sort of implicit in the idea of an agent that has its own resources and can make promises about those resources and capabilities. So in some ways, in promise theory, we're thinking that every agent is promising from within itself, contributing from what it has within itself towards a greater whole by cooperation. But boundaries take on different types. There are boundaries in what I call space, time, and process. My friend Daniel Mezick likes to call time, task, and territory. And these boundaries in time, so when jobs are bounded in time, we maybe have a promise with a time limit, a deadline, and task or within a process, a set of, permissions or authorizations. The boundaries of a task are described almost by the limits of what is possible, your constraints, and then territory, the space you have to move around in, which may include your belonging to certain teams or organizations. How do those different boundaries affect your ability to deliver on your promises, to keep your promises? So this final part is a little bit about that and how the boundaries around the packaging around something plays a role in organizations and their functions.
So rephrasing it, I need to have this urgent deploy done on production. So it's time sensitive, it's a task, and territory is production.
Let's think a little bit about what boundaries are. I think this is interesting to question because boundaries play a huge role in security, right? So when we talk about security, the first thing anyone will think about is a firewall and this kind of belief that you can put up a barrier to protect yourself from all the bad things in the world or to keep in all the things that are private. But I want to push back a little bit on that idea that there is such a thing as a boundary that can protect you. To think about boundaries as simply the edge of what we're promising. And the different kinds of things that we promise, plus and minus, so the things that we're offering and the things that we're willing to accept have limits in terms of time, task, and territory. And the way we arrange those promises, those edges of what we're willing to do are perhaps the more important thing in terms of a system.
Yeah, it reminds me of the current kind of reasoning about the concept of zero trust, where we can't say the intranet or the internet. It isn't that clear anymore. It is not inside of the building or working from home. It is not anymore. It's an employee, or like an external consultant. Yeah, it's not that clear. And even within the browser, I think about DNS and security and IP security is shifting to the application security level as well, because we can trust what the network is, who's on the network. So we're like thinking up solutions like TLS and SSL to make sure that we create our own boundary. And then even if we don't trust that, we need another boundary in the application to deal with these things. So boundaries and permissions are everywhere in security. In the threat modeling, we kind of try to figure out like what is the boundary of a system, whose authority it is. But in many cases, just reasoning and thinking, here's a hard wall is something that's impossible these days to do.
And it's even more complicated now in the age of virtualization, right? Because we have layers of technologies that create space upon space, upon virtual space, upon virtual space. And what is a boundary physically may not be a boundary virtually, and vice versa. So you go into the cloud and you set up a cluster, you have no idea whether that cluster is within the same rack, the same server, the same data center. It's probably in the same data center, but But in principle, you could also set up VPNs and AS tunnels in BGP to tunnel traffic halfway around the planet, as organizations do. So you take a big multinational corporation, IBM, Google, one of these big companies, and they will create a virtual boundary around their company, even though the actual company is distributed all over the world. And when you're on the inside, you need to go through some kind of a tunnel to move around. You may not even see that tunnel. You may perceive one kind of closure or enclosure around you and think that you're safe. But in fact, you're exposed on all kinds of sides physically through the infrastructure that's carrying that signaling or that network. So the whole concept of what's next to something else or close together or enclosed, protected is now far more complicated than it ever was.
Yeah, and even if you would see territory as the developer's laptop, the test environment, and the production environment, there are even like different approaches there as well. And on the time sensitivity, an urgent patch, 0-day vulnerability will probably require different ways of dealing with it than something anticipated. So yeah, it's almost like they influence each other, right? These three boundaries as well.
So what I'm kind of proposing is that using promise theory, we can form a model of boundaries just in terms of the promises that people, things, agents make between themselves. And the idea is that the default state of any group of agents is that an agent can only promise its own behavior. So its default state is that it neither accepts nor offers anything to anybody else. It's an entirely autonomous entity, and in that sense protected. That's a little bit simplistic, and we can discuss ways in which one agent could actually consume another agent, envelop another agent, and take it over by force. For example, a company could buy another company. A human could physically attack another human and move their arms and legs. So physical attack is not beyond possibility, but most of the time we're not in a position to overwhelm another agent, and our limits of safety, security, boundaries are associated with what we're willing to do for another. And those are about promises and impositions, which we now know a fair bit about. So when we say boundaries, I think it makes sense to say boundaries between what? And the obvious thing is agents. So what are the agents? The active participants in a system. And they can form groups by collaborating with one another, often to cope with a process or perform a process together. So it may be a group of people, but unless they're actually interacting through some process, they're not typically associated with, they are naturally already separate. So it's through processes that we combine agents into interacting groups that may then, we might want the illusion of creating a boundary around that thing. And I use the term super agent, as we've done earlier, to describe a collaboration between a small number of agents, or a large number for that matter. And the edges of that boundary have to do with what those agents are willing or unwilling to do for other agents who are not part of that group. So it's a question of sort of identity. And I think that's why identity plays a key role in security. It's one of the foundations of security, the ability to identify reliably agents and distinguish agents from one another.
Yeah. I still have a hard time figuring out, like, from the previous theory, how you derive to processes, not groups. Like, why is it seeing it as a process different than a group?
Great question. We didn't really talk about that, so maybe it's good to bring that up. We did talk about conditional promises, though, and conditional promises are, if you promise me that, I will continue to promise this based on that. And that allows you to form a chain of dependencies. And those chains are a bit like logistics chains and delivery chains. They are the basis of how you form a process in which agents collaborate with one another. Of course, you can have an interior process that's you handle entirely within yourself, programming or your heart beating or whatever. But if you're collaborating with someone else, as we are doing now, then we have this kind of back and forth between us where I promise to work for a little while, and when I stop, you promise to carry on, and we have this thing going on between us. So it's through those dependencies that we form processes, and that makes agents dependent on one another, and it allows them to form a process. A group might just simply be a collection of agents, or people, or things that are similar or have similar access to something. That doesn't necessarily mean that they have a boundary around them in any sense. In a way, by having a similar role, that might give them a kind of a common identity. So when agents have a similar role, like we're all developers or we're all security or all ops, that gives us a kind of a badge to wear, but that doesn't necessarily isolate us from anyone else.
Yeah, that's interesting because sometimes I say when people ask about DevOps, what has changed is that like nobody was stopping us from collaborating 10 years ago. Like nobody was saying you cannot collaborate. And just by that we were in these groups, we thought like, yeah, we're in this group, so we don't have to take part of the process outside of a group. And I guess that's what you're saying with the process is the fact that you are interacting, that you are almost like exploring those boundaries together as part of this process. That makes more sense.
And you're right. I mean, 10 years ago, we loved to talk about silos in companies and even said that these are bad things to have, right? Because they tend to, just as modules in software can give you the illusion that you're all safe and secure and all the tests pass within this apparent edge or limited scope. But that limited scope doesn't actually make any promises about what it will or won't do necessarily with the outside world. If you try to separate entities within an organization so that they can't communicate, they don't overlap, they form a kind of hierarchy of totally separate silos, it may cause problems for the processes that you're trying to enact or deliver on. But now it's almost, we've worked so hard to do away with those silos, or at least give them new names, although we're now thinking that we have to protect the assets of those processes somehow with additional security, so put them back somehow. And often it's not clear to me what we mean by what exactly do you want from security? What do you want your security to do? Are we trying to protect dev from ops or ops from dev? Or are we trying to protect the whole thing from the customers? Or are the customers not the problem? Is it our competitors that are the problem? How do we identify who's in and who's out of these boundaries? So why do we need a boundary? Should it be permeable, and by whom should it be permeable? What kind of permissions do we want to grant to people on the inside and on the outside of this collaboration? And what does that even mean? So those are kind of the questions that I try to answer with promises. And the way that I go about it is to start with patterns of promises, exactly as we would do with anything else. We build from the bottom up. So we start with the rules. Every agent's an autonomous thing. It's separate. It owes you nothing. It will give you nothing or receive nothing from you unless a promise has been made. So a single agent can make a promise, and a group or a collection of agents working together can make a promise. Agents come together to form a super agent, and that super agent can make promises to another super agent. Those can form a collaboration. And the key thing, I think, is the acceptance promises. Again, we always think about the plus things, what we're willing to do, but we often forget about the minus promise, the negative promises, which are about accepting stuff. Am I willing to take something from you? Because if I'm not, I'm sort of closed off and there's a natural boundary. If I am willing to accept something from you, then I'm potentially vulnerable as well to ways in which you might abuse that access. And a lot of vulnerabilities in software, of course, are caused by promises we didn't know we'd made, or promises we made which weren't quite as precisely specified as we hoped they could have been. And people saw a way to exploit that promise to do more than we actually intended. We can use promise theory, I believe, to be more precise about those promises and to identify where potential vulnerabilities may lie.
Yeah, it reminds me of a cloud service making your promise that they're doing A, B, and C. And then you have to read somewhere in the fine print, there's this limit, there's that limit. So it's already a good thing when they're explicit about their limitations, because then at least you are aware of that and they're not overpromising in all conditions. And I think that's an important part of a cloud service, to not only describe what they do, but also the conditions and the clear failure cases or anything that is like not that straightforward usual.
And actually the counterpoint to security, where security is usually focused on preventing things, but the counterpoint to that is, what if proper things can't happen, mission critical things can't happen? Like if you're flying a plane and suddenly you run out of memory, that's not good, right? The plane shouldn't crash because you run out of memory. Similarly, the banking system shouldn't crash because you're short of a computer, and your cloud operation shouldn't crash because there's a limitation in the spec of the virtual machine. So acceptance promise is super important, and conditional promises by implication are equally important, because a conditional promise has to accept a dependency in order to make its own promise. So that's how we chain together things into processes. I can promise you X if and only if you can promise me Y, and I accept Y. And it's that little tiny bit of algebra there which plays a huge role that we very often forget about in systems. Not only if you promise to deliver Y, but if I remember to accept Y, and if I am capable of accepting Y, and if I do it on time, and and all of the other ifs that are my responsibility as downstream to fulfill my role to make it happen. Time, task, and territory have different semantics. So has everyone in my group promised not to talk to my competitor? And has everyone in my group promised not to read emails from phishing scams and all of the various policies that we make associated with security? These are how we essentially define boundaries. And the notion of a firewall is often a choke point for communication, but that may or may not be fooling ourselves about whether it's is it a real barrier to communications coming in, or are there in fact backdoors and other methods of implicit communication? I remember when I was teaching security years ago, we talked about covert channels, where a covert channel is a channel that you weren't even aware of, where you're able to get communications in and out of this, the apparent barrier that you've created, or you think you've created, to affect the system in some way.
Yeah, and I think if there's any lessons learned from managing a firewall at scale, it's that there's always going to be exceptions, right? And there's always going to be, well, the business kind of asked for this. And this always was my fear about getting an audit, that like the firewall wasn't this clean thing that was so exact, but there were this number of exceptions. And that I thought the auditors wouldn't understand why these exceptions were made in the firewall. And that was because, it helped other people keep their promises, that these things were opened as well. But, if that would be only looked on from the security person or the firewall perspective, like any port that was open was a bad thing.
Yeah, that's the typical mentality. Shut down everything so that nothing works. And I remember when we used to do worked with CF Engine, we used to look at the STIGs, which are the American government's requirements, especially for Windows machines. Once you'd closed all of the loopholes and locked everything down to comply with the STIGs, your machine actually didn't work anymore, right? So it was not possible to run the software that you needed to do your job.
Yeah.
And again, this kind of toss-up between security and mission criticality. If you have a single choke point, you've created a single point of failure. So that might make it easy to secure your boundary with a fake barrier, a firewall. But then if you need a backup, because you need to be mission critical, you'll need a second entry point, a backup network connection from a different provider. Suddenly now you've got two choke points instead of one. Is that acceptable? Or what if you now have three? Or how many are you allowed to have actually before it then becomes simply porous and you shrink your surface back to the individual agents again? Again, I remember going back to the days of CF Engine when the idea there was to make every server an independent entity with its own
perimeter. Yeah.
Then we had this notion of shrinking the firewall back to per server, right? The virtual firewall. And that's still popular in some organizations. But the simplicity of this notion of putting a moat around your system, like in the old castle days, is so appealing to people at a visual level. I think it's hard to get away from that.
Yeah, and your point also reminded me that making these promises within the project or the project delivery or to production, there's also in companies another place where promises are made. That's often in sales and contracts, and dealing with those as well, and then the impact they have on the production. It could be a good thing also, like simplify architecture so it becomes less costly, or delivering things in smaller batches. And quite often they too are imposing all the wish list of a contract of all the things that you need to do. And then when you start having a good conversation and negotiation between the agents in the system, instead of saying, well, you're giving a promise for the company that nobody can keep, but you made it. That's yeah.
So the natural question is, have we satisfied the assumptions of promise theory if we're going to apply that to an organization or to a group, to a boundary? And that means, have we satisfied the idea that no agent can make a promise on behalf of another agent? Each promise has been understood and accepted by the agents, and if there are any conditionalities involved. And if we try to think at the level of a group, putting a boundary around a whole group, like say dev or ops or something like this, often what that means is imposing upon those agents, you must follow this security policy. But we have no way of verifying that or validating it if we impose upon them from the outside, because the source of the intent, again, is not the place where the intent will be carried out. And that's the problem with impositions, why impositions tend not to work. We need to turn it around into a story about promises in which each one of the elements of that group individually agree that they will promise according to this standard, like the STIGs or PCI compliance or any of these kind of sort of compliance regimes. We can try to make uniformity to describe barrier as the identity of having a common security policy. But that's slightly different from saying we're going to build a wall around it to protect it, because that might not be physically doable or virtually doable. But the idea that we can get everyone to work together comes back to this, makes security actually a similar part of the same problem that we've been talking about the whole time about collaboration between apparently different parts within a group, whether everyone within the same dev team or the same ops team or the DevOps team or the DevSecOps team, are they all following the same set of promises and keeping the same set of promises, or whatever is appropriate for their role within an organization?
Yeah, it's going to be challenging for people to accept that point. In a way, it seems also to be saying, like, assume failure. Like, you don't know whether somebody else can kind of be able to deliver on their promise. Then we kind of go from one cloud to 2 clouds or 5 clouds, or 5 people working on the same project and see what happens. Like there's like creating these options in creating choice to be able to fulfill your promise. And I think it's part of an agent to almost to drive generating options for other people and for themselves, so they kind of have the possibility that they can keep delivering their promise. And part of security there as well is that if you just control it too much and you don't creating options for people to do either the right thing or standard changes or options that they can have this feeling that they have a choice, it's just going to be counterintuitive and not having the effect.
I mean, it's true, right? That most managers would simply say, what are you talking about? I simply tell you what to do, you do it, and if you don't, there'll be hell to pay. Mm-hmm. And that goes back to this story with Mary and the developer again, like if you don't do it, if you don't do what I impose upon you, I will blame you. But that's totally ineffective. The blame is an imposition. It will not solve the actual problem, which was that the security was breached. The permissions were, the exploit was exploited. It might make you feel better because that kind of blaming action is a way of distributing your own shame because you didn't do your own job properly. But if you could actually turn it, if you're serious about security, you would think, let's not get to the point where we're trying to blame people for things that shouldn't have happened. But let's try to stop those things from happening in the first place, which is the true purpose of the security. And that's where I think promise theory has a very clear message, which is that you should do it from the bottom up, from each of the entities individually, and seek homogeneity of policy from the inside out, rather than trying to build a wall around it to protect the disarray that you've mismanaged on the inside of your barrier.
But some would say it is related to the size of the risk you're taking, right? If the risk's too big, we do not allow any freedom. If it's okay, we can create like this, the company is permissive of failure, or your systems are permissive of failure, then it becomes easier, of course, because then we're resilient. But in many cases, security people would argue, yes, but if the worst thing happened, that needs to be exactly driven like that. But I think, Chernobyl is a good example of trying to control all the variables and then not leaving the variables on the field, or going to the moon, kind of this freedom that we rely on humans to make the right decision as well. So
I think that's exactly right, because, and this goes back to IT culture now, especially security culture, but IT in general as an industry, as a profession, as a science, if you will, came from this origins of logic. And logic is a very simplistic story about processes that happen, simple linear flowchart like processes that go step by step, and it's very clear whether they go this way or that way. It's if this way, if not, then that way. And it's all very locked down, and it's very simple to understand. It's a lovely story, but it ain't like that in reality, because the systems that we connect together is form networks, and those networks create alternative pathways which allow you to sidestep some of that logic. So the simple idea that it's yes or no is just not true in IT. And it certainly isn't true when we try to scale systems, because the difference between true and false might be a decimal place in some count over resources, which changes dramatically with scale or traffic levels or user levels. All kinds of different circumstances come in. So if we make a very rigid policy, as security people often try to do in order to make it clear, if we seek clarity and put clarity ahead of resilience, we're almost certainly going to lose when we try to adapt the system through scale or through changes to specifications, a new version of the software. I don't like to use the word naive because it sounds pejorative, but it is a bit naive to think that you can lock something down completely in the way that security people often want to do, because it just doesn't work.
Yeah, and I would say that we are naive of giving people freedom. So, yes. I think that makes the circle go around. So,
and that's the dilemma that we face, right? So that's why I think this concept of DevSecOps is interesting, because just as Dev and Ops had their, sitting on their high horses and preaching to one another about right and wrong, so security comes in and they have their own set of values. And one of those values is keep it simple, lock it down. Don't allow freedoms that are, even if it's user-friendly, forget user-friendliness, security comes first. And those trade-offs still need to be made and resolved by somebody.
Yeah, I want to leave on a positive note that there's people changing, in their mentality, much like, people changing in Dev and Ops in this collaboration and putting this collaboration first. So, that's the excitement for me in the field, that, these are explored now more than they were before.